Good morning, students. I'm Meenakshi from Rohini College of Engineering and Technology. Today, we are going to see the topic Secure Hash Algorithm in the course Cryptography and Cybersecurity. So, SHA, it is known as Secure Hash Algorithm. It is one of the hashing algorithm. It was originally developed by NIST, and it is published as the standard FIPS 180 in the year 1993, and it is known as SHA-0, and it has some disadvantages. So the algorithm is revised, and it is again published in the year 1995 as SHA-1. So SHA-1 algorithm produces 160-bit hash value. We have so many versions in the year 2002, and they are named as FIPS 180-2, and it has three additional versions: SHA 256, SHA 384, and SHA 512. So why they are named as SHA 256, SHA 384 means they are producing 256-bit hash value, okay, and 384-bit hash value, 512-bit hash value. That's why they are named as SHA 256, SHA 384, and SHA 512, and they are collectively known as SHA 2. They follow the basic structure as SHA 1, but with greater security. It offers a greater security. The most recent version is FIPS 180-4, and it has added two variants of SHA 512. That is, under SHA 512, now we have two variants, 224-bit and 256-bit hash sizes. As I told, SHA 256, SHA 384, SHA 512, they are collectively called as SHA 2, and they follow the same structure as SHA 1. That is, it uses a modular arithmetic and logical binary operations to implement the hash function. This algorithm takes as an input a message with the maximum length of less than 2 power 128 bits. Okay, so its length of the message is less than 2 power 128 bits, and it produces a fixed size hash code, and its length is 512-bit messages, and every block of input is processed as 1024 bits. So this is the general structure. So SHA algorithm takes as input a message with the maximum length of less than 2 power 128 bits, and the output of this algorithm is 512-bit hash code, and we are processing the input as 1024-bit blocks. So this is the comparison of SHA parameters of different versions. So message size. So SHA 1 algorithm, so it requires the message size should be less than 2 power 64. Up to SHA 256, it is of length 2 power 64, and for higher version, the message length should be less than 2 power 128. And the word size, while processing the blocks, the word size is 32 for SHA 1, SHA 224, and SHA 256, and for the higher version it is 64. And the block size is 512 for SHA 1, SHA 24, SHA 224, and SHA 256, and for higher version it is 1024. And what about the output size? That is the message digest size. That is the hash code sizes: 160 for SHA 1, 224 for SHA 224, 256 for SHA 256, 384 for SHA 384. Okay, so like that. And the number of steps we needed are 80 for SHA 1, 64 for SHA 224 and SHA 256, and for all the others it is 80. And security, it is measured in terms of brute force attack. So it requires 80 for SHA 1 and 128 for SHA 512 and SHA 256. So this is the comparison of different versions of SHA. So this is how the message digest is generated using the SHA algorithm. So initially we have the message the length of the message is represented as L. So it should be added if necessary with zeros. So it is known as padding. So padding is always adding 1 followed by zeros. So why we are doing this padding operation means, so we have to convert the message into 896 modulo 1024. Okay, so we have to make the message length is congruent to 896 modulo 1024. Okay, so why it is taken as 896 means 896, then we have added the length of the message 128. So it is totally 1024. Okay, so that's why it is specified as padding is done so that the message length is congruent to 896 modulo 1024. So as I told, padding is nothing but single 1 bit added with the necessary number of 0 bits. Okay, so then we have added 128 bits length of the message. So it is the length of the original message before adding. Okay, so now the message is of multiple of 1024. Okay, this is our aim. So then the message is divided into equal number of 1024 bit blocks, and they are named as M1, M2, M3 up to Mn, and each block is given with the hash function, that is the heart of the hash function f. Okay, so initially it is also delivered with initial vector of length 512, and each block is processed. After processing, we get a value, and that is XORed with the previous hash value. After processing n number of blocks, finally we get the 512 bit hash code. Okay, so this is the overall processing. So the first step is padding. Original message is padded. What is the condition? 896 modulo 1024. Padding is nothing but adding 1 followed by extra zeros. After padding is done, we have to add 128 bit length. So this length represents the length of the message before padding. After that, we have to initialize the hash buffer. So 512 bit hash buffer is used to hold the intermediate and the final result of the hash function. Okay, so the buffer can be represented as 64 bit registers, that is A, B, C, D, E, F, G, H. So each is of having 64. So 64 into 8. So totally we have 512 bit buffer. So initially this 512 bit buffer is initialized by initial vector. Okay, so third step is initializing hash buffer. So using that buffer only we are storing the intermediate result and the final results. Okay, in the fourth step we are processing the messages 1024 bit blocks. Okay, so for processing we are using the module which consists of 80 rounds. Okay, so it depends upon the SHA version. So it consists of 80 rounds. It is the heart of the SHA algorithm, and this module is labeled as F. Okay, so that is this one. This one. Okay. Finally, after all the n 1024 bit blocks have been processed, we get the final 512 bit message digest. So that's about the message digest generation using SHA algorithm. So now we move on to the heart of the module F. So as I told, it contains 80 steps, okay, 80 rounds, 0 to 79, and it requires 8 buffers, each of having length 64. Okay, so A to H. So each and every round it updates the value of the buffer. Finally we get the 512 bit hash value. For every round you have to supply 3 inputs. One is the previous hash value, the previous round hash value. Then another one is word, obtained from the original message block. Okay, so for a particular round we have the message block. From that message block you have to obtain 80 words. They are named as W0, W1 up to W79, and along with the previous hash value and the message word you have to supply the key constant also. So key constant also distinct for each and every round. Okay, so each round takes the 512 bit buffer value A, B, C, D, E, F, G, H, and in every round we have to update the contents of the buffer. In the first round the buffer has the value of the previous hash value, and it takes a word derived from the current message block, and also it takes an additive constant. Okay, it also distinct for each round. Okay, so the operation performed in each and every round consists of circular shift and the primitive boolean function. So it can be AND function or NOT or XOR. Okay, so like that we are doing 80 rounds. After performing the final round, the output is XORed with the previous hash value. So it is this addition is not an individual addition, it is modulo addition. Okay, after performing modulo addition 2 power 64, okay, we get the final 512 bit hash value. So one important thing of SHA 512 algorithm is every bit of the hash code is the function of every bit of the input. Okay, and we also repeat the same basic function 80 times, so the outputs are well mixed. So if any two messages are chosen in random, even though they will exhibit the similar regularities, we will get the different hash code. Okay, we won't have the same hash code. Okay, so this is the security of hash algorithm. With this I am concluding the SHA algorithm. Thank you all.